Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. Sorry, my tongue just slipped there. That was weird. Um, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called EPSA Leftover Number 2, Little Palindromes by Richard. And here are the rules. We have apply classic Sudoku rules. So that means in every row, in every cell in the grid. I don't know what's going on with my well, that one was my mind. The previous one was my tongue. I don't know what's going on. In every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Clues outside the grid indicate the sum of the digits of a palindrome that is located somewhere in the diagonal direction of the arrow. And it consists of at least 3 digits. So every diagonal must be the sum of a palindrome, which is at least 3 digits long. Okay, that's interesting. So, for example, this has to be a palindrome. So that means it must go the same this way as it does this way. It must read the same one way as it does the other way. And this one, for example, must add up to 13. This must add up to 12 as a palindrome. And it has to be a palindrome, interestingly enough. So the thing is, for example, you could have something here like 313. And this would be valid because along this diagonal is a palindrome, 313, which adds up to 7. And that's an example of how these diagonals work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. This adds up to 4. And it's the only possible combination would be 1, 2, and 1. I saw something here which made sense. So here, this adds up to 48. But these 6 digits are broken up into 2 sets, which must be unique. And the most we can have for 3 unique digits is 7, 8, and 9, which adds up to 24, which is exactly half of what 48 is. Therefore, this must be 7, 8, and 9 here, and this must be 7, 8, and 9 along this diagonal. Well, to add up to 4, it must be 1, 2, and 1 to add up to 4 if it's 3 cells long. And since this can't be 1, this has to be 1 or 2, and then that's 1. So we have that combination. This adds up to 24. But none of these digits can be. What are the possible combinations? You can't have 888, and I guess you could have 888 here, but since this can't be 7, 8, or 9 because of a 7, 8, 9 triplet in the row. This can't actually be 888 here. 7 on the sides don't work because you must be around a 10. So you cannot ever have 3 digits on this palindrome adding up to 24, right? because again, it's a palindrome, so two of the digits have to be multiplied together. Actually, I guess you could have 998. So I guess this could be 989 there. So that's a possibility. Okay. This is a palindrome that adds up to 31. And this is at maximum 5 and 6. So 5 and 6 adds up to 11. Plus another 5 and 6 adds up to 11. That's 22 at most. And this can be 9 at most. So to fulfill this 31, you have to get the most digits here. So this must be 5 and 6 as a pair. So we have 5, 6, 5, 6, and this has to be a 9. Which eliminates 9 here and here. This adds up to 30. The remaining digits in box 6 are 1 through 4. This is at most 3, 4, and 9, which is 16. So if this was a 6-length palindrome, which it could be. Oh, it cannot be that. It cannot be. Okay, so yeah, it cannot be a 6-length palindrome. The reason why we know that is these two digits are the same digit as a palindrome. So therefore, these two digits can never be the same. So if these two digits are the same, this is a 6-length palindrome this way, these two digits have to be the same. But we also know that these two digits are the same for this palindrome here. So because of that, this cannot ever be a 6-length palindrome, which means it's 5-length at most. Can it be 4 in length here? I think the answer to that is no, right? This is 9 and 4 at most. And so if we had we've had these 4, it would basically be 3, 4, 9. And first of all, these wouldn't be a palindrome. These can't be the same digits. So that's not possible. So it would have to be something like this. But again, you have the same problem of this being the same digit as that. So it essentially have to be like that as a palindrome, and you can't have those two cells being the same digit. So this digit must be a 5-length palindrome adding up to 30. So this has to be 7, 8, or 9. This is 1, 2, 3, 4. It can't be 1 because of 1 in the box. Can't be 2 because of 2 in the row. So this can't be equivalent 1 and 2. It's 3 or 4 there. So it would have to be at least 13 here. It adds up to 30. So this must be an even digit, right? Because these are the same as these. That's an even number, plus an even number gives you an even number. So this is 2, 4, 6, and 8. Can it really be 2? Probably not, right? Yeah, this is at most 13. 13 plus 13 is 26. So therefore, it would be 4, 6, or 8 there. Interesting. Remaining digits in... So this digit is the same as that digit. So let's mark where these are. It's the same as that digit, which is the same as that digit. So this one must be one of those two. This is a palindrome, and it must be 3 in length. This has to be 7, 8, or 9 here, but 7 plus 7 already adds up to 14. So this cannot be the palindrome. This is the palindrome here. So let's mark all the palindromes. So we have one there, we have one here, we have one here. 24. So this, if we try to have this as 3, it could work, as long as it's these 3. Can this actually ever be 7? Yes, 7, 4, and 8. But the problem is then, if we try to make this a 3-size palindrome, because this is not going to work. This is 6 and 5 at most. That's 10, which means that has to be 14 if that's 3. So if this is 3 that way, it has to be 9, 9, and 8. But the problem is that forces this to be 9 and 8. That's 7 and 4, and 4 and 7. But that means 4 and 7 plus is 11, times 2 is 22, and this would have to be 8. So this cannot be 3 digits as a palindrome. This can't be 1 because of 1 in the column. So this has to be a 4-size palindrome at least, and I don't know if it works. It would have to be, well, maybe it works. If it's a 4-length palindrome, that means each of these add up to 12. So it would have to be 3 with 8 or 9, or 3 with 9, or 4 with 8. Well, it could not be 3 and 9 here, so it would have to be 4, 8, because of the 9 in the column. So it would have to be 4, 8, 8, 4, which makes this 6. And that would be 3 and 9. That does work, actually, interestingly enough. Pink can't be here or here. That's not helpful. What about a 5-length palindrome? That could work also. So if it's a 4-length palindrome, it has to be 4, 8, and 8, 4. That would make this 6. That means this has to be 30 minus 6, which is 12. So it'd be 3 and 9 and 3 and 9. So that could work. Otherwise, this is a 5-length palindrome here. This must add up to 13. These two digits are the same, and this must then be odd, because these would add up to 2 times something, which is even, and it must add up to an odd sum. So this is 3, 5, 7, or 9. 3 would force this to be 5 and 5. 5 would force this to be 4 and 4. 7 would force this to be 3 and 3. 9 would force this to be 2 and 2, but it can't be 2 because of 2 in the row. So this can't be 9. So those are the possibilities for this palindrome here. 31 is done as a palindrome here. This is 31 also. That means you have to have an odd number of digits. If you have an even number of digits, they must be the same. If you have 4, you have 2 and 2, which are the same digits, which means you cannot have, right, this cannot be a 4-length palindrome. And it can't be 3 because 3 digits can never add up to 31. So this must be a 5-length palindrome this way. Interesting. And this has to be an odd digit also, because again, it adds up to 31, which is an odd value. This has to then be 3, 5, 7, or 9. We cannot have 1 in either of these. 9. So again, if this is a 4-length palindrome, it's 4, 8, 8, 4. If this is a 5-length palindrome, this would have to be an even digit, so before 6 or 8. what else do we have? So this can never be 2. Because as a 4-length palindrome, it must be 4884. As a 5-length palindrome, it would have to be the same digit as that, which means it can't be there. So either this is 4 and this is 3, which means 4 cannot be here. Or this is 3, 4 being 3, 4 there, which means that can't be 4 either way. So this can't be 4 either way. It's 6 or 8. So this has to be 4, 5, or 6. This has to be 8, 3, or 4. This is 3, 4 as a pair. We have 5, 6, 5, 6 there. So these either add up to 12 when it's 8 here, or 13. Which means this is always going to be 9. Right? If it's 12 here, 8, that's only when it's 4, 8, 8. Well, I guess this could be 8 here. This can never be 7, is kind of the point. I guess. It could be 3, 9, or 4, 8, possibly when it adds up to 12. When it adds up to... we know 2 has to be one of these 2 digits here. So what happens if we have 4, 8 here? 4, 8 is 12. Yeah, it can't be. So if we have 4, 8 here, that makes 4, 8s here, which means this is 6. But 4, 8 is 12. Oh, I guess that works. So it'd be 4, 8, 6 here. This would then be 5 and 3. And then 5 and 3 here. And this would be 8. So that is possible. So this can never be 2. Because either this is 4, 8, 8, 4, or this is a palindrome with that cell, and it can't be 2. This is 3, 4 as a pair. This can't be 3, 4, or 2. It's 1 there. This can't be 3, 4, or 1. It's 2 there. Interesting. So this is 8 or 9 here. This is 3, 4 as a pair, which means this can't be 3 or 4. It's 5, which means this is 5 as a palindrome, and this is 3, so it's 3, 5, and 3. Which means this cannot be 3 or 5 because of 3 or 5 in the box. So this has to be 7 or 9 here. If this is 9, 31 minus 9 is 22. 22 divided by 2 is 11. So then this would have to be 5, 6, or 7. Add up with a 4, 5, 6. Can't be 5 here because of the 5 in the box. If this is 7, or 5 in the row, I should say. And actually, if it's 9, this can't be 5 either. So if it's 9 here, this has to be 4 and 7 and 4 and 7. Okay. Right? So if we have 9 here, that's 22, so this must add up to 11. We can't have 5 here. And this is only 4, 5, or 6. So therefore, it has to be 4, 7. If this is 7 here, that means these add up to 7. 31 minus 7 is 41 minus 7 is 31 minus 7 is 24. 24 divided by 2 is 12. So if it's 12, this can never be 6 for first of all. And if we try to have this as... You cannot have 5 here. So it has to be 4 here. So this is guaranteed to be 4. And it's with 7 or 8 here. 4 forces this not to be 4. So this is 3. This has to then be a palindrome of 4884. Because there's no other place for it. So this is 4. This is 3. This is 4884 to add 24. 3 and 3 add up to 6. This can't be 8. It's 6 here. 30 minus 6 is 24. 24 divided by 2 is 12. So this is 3 and 9. So we have 3 and 9 here, which forces this to be 9. 8 eliminates 8 here, so it's 7, which eliminates 8 here. So that's 7 also, which makes this 8. That makes this 8. This 8 eliminates 8 here, so it's 4, 7. And this is 7, 4 as a palindrome. That's 11 plus 11. That's 22. Plus 9 adds up to 31. 6 eliminates 6 here, so it's 5 and 6, which that forces this to be 5 and 6 that way. So this is the palindrome there. This is getting kind of confusing with all these greens. Okay, so we can remove the pinks. This palindrome will mark as green. This one will mark as medium. This will mark as dark. This will mark as orange. We need pink this way. This we still haven't figured out. This will mark as yellow, and this will mark as red. So we still need to figure this out here, and the 7. Okay, remaining digits in box 2 are 2 and 5. Remaining digits in row 3 are 4 and 7. This can't be 4 because of 4 in the column. So this is 7, this is 4. Okay. Remaining digits in box 9. Sorry, box 8 are 1 through 4. No 3, 4 here because of 3, 4 in the column. This is 2, 3, 4. So as a 3-length palindrome here. So either it has... Okay, so this cannot be a 3-length palindrome. You could have a 4-length palindrome, though. So it can't be a 3-length palindrome here. What are the remaining digits, actually, in column 7? We have 4, 5, and 6. Interesting. This can't be 5 because of 5 in the row. This can't be 6 because of 6 in the row. And no 4 here because of 4 in the row. So we're guaranteed one of these has to be a 4. Column... Let's do column 6. Actually, let's do that cell here. No 1, no... It could be 2... No 1, it could be 2, no 3, 4, 5. Can't be 7 or 9, so it's 2, 6, or 8 there. The palindrome here cannot include this because that would have a 7, and that's already greater than this. So actually, that doesn't matter. Remaining digits of column 6. We have 2, 3, 4, and 9. No 3, 4 there. No 4, 9 here. No 2 here. Okay. So as a palindrome here, does anything work? Not really. Yeah, you have to have... So 1 has to be part of the palindrome. Because it can't have 7, so therefore it's 3 in size. It's either there, or there. If this were the same as that, which it can't be anyways, it would be 5, 1, 5, so it has to be 1, 5, and 1. So this is the palindrome here. And how does this work as a palindrome? It could be a 4-length palindrome with 2, 2, and then 4, 2 there. That is possible. Or it's a 3-length palindrome this way. It cannot be 4 because then that would require 4 and 4 here. What about 6? 6 could work with 3 and 3. So either this is 2 and 3 as a pair then. Because either it's a 4-length palindrome, which forces that to be 2, or it's a 3-length palindrome, which would force this to be 6, 3, and 3. We have a 2, 3 pair then in column 6, which eliminates 2 and 3 in the rest of the column. There's no 2 or 3 here. It must be 9. Oh, 1 here eliminates 1 here, so that's 2. Well, there we go. This can't be 2 then, so it's 3, which makes this 2. 3 and 9 can't be here, it's 4. This must be a 3, 6, 3 palindrome, not 6. 3, 6, 3. So this can't be 1, 2, or 3, it's 4, which means this has to be 1 here. 2 eliminates 2 here, so it's 5 and 2. 6 eliminates 6 here, so it's 5 and 4. So this is done as a palindrome also. And we are all done, actually. So we have 1, 2, 1 adding up to 4. 5, 3, 5 adding up to 13. 4, 7, 9, 7, 4 adding up to 31. 4, 8, 8, 4 adding up to 24. 9, 3, 6, 3, 9 adding up to 30. 3, 6, 1, 5, 1 adding up to 7. 3, 6, 3 adding up to 12. 6, 5, 9, 5, 6 adding up to 31. And 8, 9, 7, 7, 9, 8 adding up to 48. So the rest is just normal Sudoku. Remaining digits of row 4, we have 1, 2, and 6. This cannot be 1 or 2 because of 1, 2 in the column, so that's 6. This can't be 2 because of 2 in the box, so that's 1, which makes that 2. Therefore, this can no longer be 2 here. Remaining digits of column 4. We have 3 and 5. 5 can't be here because of 5 in the row, so this is 3, which makes that 5. Remaining digits of column 5. We have 7 and 8. 7 can't be here because of 7 in the row, so this is 8, 7. Remaining digits of row 5 are 3 and 8. This can't be 3 because of 3 in the column, so this is 8 and 3. Remaining digits of row 6 are 1, 6, and 9. So we don't have any that much information there. This 9 eliminates 9 in the rest of the column. Remaining digits of row 7 are 5, 6, and 8. And this can't be 5, and this can't be 5. So where's the 5 in row 7? It must be here. We have a 6, 8, 6, 8 pair in column 3, which eliminates 6 and 8 in the rest of the column. So this can't be 6, it's 1. So therefore, no 1 here, no 1 here. Remaining digits in column 3 then are 4 and 7. This can't be 4 because of 4 in the row. So this must be 7, and that must be 4. Okay. Remaining digits of row 2. Well, one of the sets is 1 and 4. And 1 and 4 cannot be here because of 1 and 4 in the box. So this must be a 1, 4 pair, which eliminates 4 here because of 4 in the column. So this is 1, that's 4. That leaves us with 6 and 9 remaining in row 2. This can't be 9 because of 9 in the column. So that's 6, that's 9. We have in box 3, the remaining digits as 3, 7. This can't be 3 because of 3 in the column, so this is 7, that's 3. 3 in the corner, we celebrate because we're close to solving this. Remaining digits of column 8 are 2 and 8. 8 can't be here because of 8 in the row, so this is 2, that's 8. Remaining digits of column 9 are 5 and 7. This can't be 5 because of 5 in the row, so this is 7, 5. Remaining digits of row 8 are 2 and 3. 3 can't be here because of 3 in the column, so this is 2 and 3 there. Remaining digits of row 9 are 1 and 9. This can't be 1 because of 1 in the column, so this is 9 and 1. Which means this can't be 9, it's 6 and 9. 6 eliminates 6 here, so it's 8 and 6. This can't be 6, so it's 8, which forces this to be 2 and this to be 6. And that's how you solve it. Very cool, actually, concept here of these, like, little palindromes. It's an interesting restriction. But I could see it being very, like, it doesn't have to be very restrictive, actually. The only restrictions we have are that the palindrome has to be 3 in size. So it's pretty flexible about what you can do, since you have a wide variety of sums you could use. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.